Research means studying things we don't yet understand. As Einstein put it, if we knew what we were doing, it wouldn't be called research, would it? So how do you go about studying something that you don't understand? Science's answer to this is to use a structured approach called the scientific method. We normally start from a hypothesis. This is something that's somewhere between an idea and a theory. The hypothesis can come from another experiment that has thrown up some interesting facts, or it can come purely from inspiration. For example, suppose while I'm visiting a wildlife park, I notice some flamingos that are standing on one leg in a lake. I wonder if they stand on one leg to try to keep their feet dry. So this now becomes my hypothesis, that flamingos stand on one leg to try to keep their feet dry. The next step is to design an experiment to test whether the hypothesis is true. We have to design the experiment to take into account all sorts of things that could go wrong, and we'll cover those on other pages on the website. Having designed the experiment, we then have to carry it out. Now, to test our hypothesis that flamingos stand on one leg to try to keep their feet dry, we might predict that if this is the reason for them standing on one leg, then when they weren't in the lake, they would put both feet down on the ground. So we could design an experiment to test if the flamingos accustomed to standing on one leg in the lake, when they're put on dry land, put both feet down on the ground. The next stage of the scientific method is to interpret the results of the experiment. We have to see if the results support the hypothesis. If the results do support the hypothesis, we've discovered something. But we also have to be critical of our own results. Could anything have gone wrong? In the case of the flamingos, if they still stand on one leg when they are on dry land, we might conclude that the hypothesis was wrong. They are not trying to keep their feet dry after all. They stand on one leg for a different reason. But perhaps now we realize that the flamingos spend so much time standing on one leg when they are in the lake that they might have become used to it, and so they continue to do so even when they are on dry land. This may be the reason they keep standing on one leg, so our experiment may not be telling us anything about their original motivation for standing on one leg. We would have to be a little bit cautious about drawing any firm conclusions from this experiment, and we really should have designed a better one. The last step is to incorporate the new knowledge we've gained from our experiment into our understanding of the subject we are studying. Now, invariably, the scientific process throws up new questions, and we have to address these with new hypotheses, so we have to start again at the beginning, dealing with those. Now, not all science falls into this rather neat pattern. Sometimes we're answering the question, I wonder what would happen if I did this or if I did that. Sometimes we're addressing a technological challenge, which we hope will lead to some useful advances along the way. Sending a man to the moon probably fits into this category. Other experiments are done deliberately just to throw up new ideas. And lastly, some science doesn't involve laboratory experimentation at all, but rather it depends upon computer modeling or developing theories or simply observing the world around us. Science can also be broken down into basic science or applied science. In basic science, we're trying to understand the way the world, or the universe, around us works. Whereas in applied science, we're trying to achieve a specific objective. Understanding why flamingos stand on one leg is basic science, but trying to find a new drug to treat influenza would be applied science. The term translational science has recently become fashionable, and that refers to science that is done to translate the findings of basic research into real-world applications. Now, all of these types of research are important. Without the basic research, we wouldn't have the necessary knowledge to even start to do the translational research. Although it might sound like the translational and applied science are more useful, the basic science is really where the ideas come from in the first place, so in fact we need all three.